Alright, so here's the fourth example using the shell method. So the formula is the volume, V, equals 2 pi times the integral a to b of p of x. P of x is your radius to the outer of the shell, or the rectangle. We'll draw a rectangle to represent the outer shell, times h of x, which is the height of the shell or the height of the rectangle, times the thickness of the shell or the thickness of the rectangle, the dx or delta x. Alright, so let's take a look at this fourth example. It says find the volume of the solid formed by revolving the region bounded by the graphs of y equal x cubed plus x plus 1, y equals 1, and x equal 1 about the line x equal 2. Alright, so let's go ahead and draw our picture. Alright, so let's see, 1, 2, 3. That would be 1, 2, and 3. We'll call this x equal 1, and there's x equal 2. Okay, so let's draw the graph so you can see if we put 0 in for x, that's going to be here. And this function is going to look something like this. Because if we plug the 1 in here, that's going to go up here to 3. Okay. Now we've drawn this. Now we've got to draw y equals 1 and x equal 1. So it's x equal 1. So those are going to touch there. And then y equal 1. Okay. So this is the region that we're revolving. And we're revolving it about this line x equal 2. Okay, so let's draw a rectangle in there. So there's the rectangle. Okay, now we need the radius. And remember, the radius is the distance from the axis you're revolving it around to the center of the rectangle. Okay, alright, so what would this radius be? Well, we know we're going to be in terms of x. That's delta x, the thickness. So from here to here is x. Well, if from here to here is 2, then that would make p of x equal to 2 minus x. Okay, so there's our radius, 2 minus x. Okay, because from here to here is 2, and then we have to take this x off to get this length here, this distance. Alright, now we need the height. That's h of x is equal to, okay, well, what's the height of this rectangle? Well, we know from here to here is x cubed plus x plus 1. Okay, but then we have to take off this part because see, we just need this height here. Okay, so we have to subtract off this distance, which is 1, so minus 1. So the height is x cubed plus x, because the 1's cancel out. Alright, now let's set up our integral. So the volume is 2 pi times the integral, and we're going from 0 to 1 of the radius, which is 2 minus x, times the height, which the height, you see we got here, is x cubed plus x dx. So the volume is 2 pi times the integral 0 to 1, and when I multiply this out, I end up with negative x to the fourth plus 2x cubed minus x squared plus 2x dx. so let's integrate this, and I'm gonna come down here and integrate it. So the volume is 2 pi times negative 1/5 x to the 5th plus, and then that's going to be a 4 when I add 1 and then divide by 4. So that's going to give me 1/2 x to the 4th minus 1/3 x cubed plus x squared. And that's going from 0 to 1. So now when I evaluate that, that's 2 pi times, then I'm going to plug the 1 in. That's negative 1/5 times 1 to the 5th plus 1/2 times 1 to the 4th minus 1/3 times 1 cubed plus 1 squared minus, and then when I plug the 0 in, you can see all that's going to go to 0. Okay, so the volume, once I calculate that, I get 29 pi over 15. Okay, and that's your answer. So, you know, just like I said in the other videos, you just gotta look at this and draw it out. Get your radius. The radius is measured from the axis you're revolving it around, and then you need the height of the rectangle. Okay, you can see it wasn't all of this x cubed plus x plus 1. It wasn't from here to here. It's just from here to here, the actual height of this rectangle. Okay. Alright, so I hope these videos have helped. Alright, thanks.